All right, 2.2, lesson 2.2, scientific notation with positive powers of 10. So we're going to start writing scientific notation down, and the essential question is, how can you use scientific notation to express very large quantities? And I have a surprise for you because here's the answer. Write the large, here I got to put it up top here. Write the large quantity as the product of a number greater than or equal to 1 and less than 10 and a power of 10. So when you write something, it's going to be something like this: 2 3/10 times 10 to the 4th power. And that will give us a product. So here's your product. It says the product of a number greater than or equal to 1 and less than 10. So 2 3/10 is greater than 1, and it's also less than 10. And a power of 10. Here's your power of 10. That's how you write large quantities. Okay, so we're going to be using scientific notation. Scientific notation is a method of expressing very large and very small numbers as a product of a number greater than or equal to 1 and less than 10 and a power of 10. So product means you're going to multiply. So they're going to look something like this. You're going to have a number times, that's your product, 10 to some power. Now the parts that are red, you're always going to have those parts in scientific notation. The parts that are black will be numbers, and they'll change from number to number. So the number symbol, the pound symbol there, the hashtag they call it now, those are going to be numbers. Those will change from problem to problem. The red part, the times 10, that's always going to stay. Okay, so we don't need that. Okay, the weights of various sea creatures are shown in the table. Write the weight of the blue whale in scientific notation. Okay, so we're going to write the weight of the blue whale in scientific notation. So here's our blue whale. It says move the decimal point in 250,000. Now, of course, it's right here at the end. Maybe I should make this bigger. It's right here at the end. To the left, as many places as necessary to find the number that is greater than or equal to 1 and less than 10. So I'm going to write that number so I can kind of use it. It's kind of small in the book. And here's your decimal point. So I'm going to move it over 1, 2, 3, 4, 5. I must move the decimal point over 5 times to get a number that's equal or greater than 1 and smaller than 10. And that number is 2 5/10. Why won't this let me draw this? Okay, use my finger. So when I move the decimal point over, I move it over 5 spaces. And I have a number that's 2 decimal point 5, 2 5/10. Part B says, divide 250,000 by your answer to A. So if I take 250,000 and I divide it by my answer for A, 2 5/10, I'm going to get 100,000. Now it says, write your answer as a power of 10. So 10 is my power. So let's see, I have 1, 2, 3, 4, 5 zeros. That's why you did the Are You Ready? Remember the Are You Ready? It talked about those powers and such. That's why you did the Are You Ready page. It's going to help you with this page. Now it says to combine your answers to A and B to represent the 250,000. So part A goes here and part B goes here. So part A was 2 and 5/10. Part B was 10 to the 5th power. So 250,000 can be written as 2 and 5/10 times 10 to the 5th power. Okay, then they ask us to repeat steps A through C and write the whale shark. Why won't this get smaller? Here we go. And write the whale shark also in scientific notation. So let me get rid of some of this mess. Let's see, where were they supposed to be? They're supposed to be here and here. Goodness gracious. All right, so I don't really like the way they do this. I have a different method. I think it's a little bit faster than going through all those steps. So I'm going to show you my other method. Let me get myself some white space here. Okay. And then here's the whale shark number, 41,200. Here's your decimal point. So if you don't see a decimal point, it's going to be at the very end of the number. So I'm going to move this over once, twice, 3 times, 4 times. So I move my decimal point over 4 spaces. And when I move that decimal point over 4 spaces, I place the decimal point in between the 4 and the 1. So I need the 4, the 1, and the 2. The 4, the 1, and the 2 are significant digits. The other digits I can just ignore. I don't need those zeros on the end. Scientific notation said you have to have a product times 10 to some power. So here's my number that's 1 or greater but less than 10. 4 and 1200ths is less than 10 but greater than 1. I'm multiplying it by 10 to some power. And that power comes from the number of spaces I moved it. Because every time I move my decimal place, that's a power of 10. So I moved it 4 spaces. So this, ladies and gentlemen, would be the number of the whale shark written in scientific notation. So on this reflect, it talks about the problem we just did. How many places to the left did you move the decimal point to write 41,200 in scientific notation? Remember, we moved it 4 spaces. So we can say that the decimal moved, the decimal, not just the move. Goodness sakes, Miss Sanderson. So the decimal moved 4 spaces. And then it asks, what is the exponent on 10 when you write 41,200 in scientific notation? We can say the exponent is also 10. They're trying to make you, I'm sorry, it's also 4. They're trying to have you make a connection with what I just did on the second one. The connection of how many spaces you move it actually gives you the power, gives you the exponent. Okay, so now we're on page 40, and the instructions here tell us about writing a number in scientific notation. And I'm going to take a number and move it to scientific notation. So keep in mind that whenever you write a number in scientific notation, they give an example of 84,000. So you're moving this decimal point to the left until you get a number that is 1 or greater but less than 10. So 8 4/10 is 1 or greater but less than 10. And I moved it 1, 2, 3, 4. There's your exponent. So let's try this example 1. And I believe the example 1 is filled out for you in your textbook. And if it's done that way, you learned nothing. I like students to actually work on the examples, not just look at them in a textbook. So here I have 93 million miles. So here's a number that's very large. It's the distance from Earth to the Sun. And they want us to write this in scientific notation. Now, this very large number, it's easier to work with this number if it's written in scientific notation. So let's locate our decimal point. If I don't see it, it's automatically on the far right. And I'm going to move it over 1, 2, 3, 4, 5, 6, 7 spaces. So notice how I move it over 7 spaces until I just have one number in the front of it, one digit. So there's just one digit in the front of the decimal point now. So I'm going to write the 9 and then my decimal point, because I moved it, and the 3. None of these other zeros are significant. I'm not going to worry about any of these 3 zeros. I'm going to continue on, times 10. So your exponent is the number of spaces. I moved 7 spaces. And so your exponent is 7. So here's the number in standard notation or standard form. Here's that same number in scientific notation. All right, here we have your turn. So your turn, I'm going to pause the video. You pause too. Try these numbers. Remember your decimal point's on the far right. You're going to move it left till you have one digit out in front of it. If you have your decimal point right here, you've got 4 digits out in front. Again, here's your decimal point. You need to move it over so you have one digit in front of it. Here's a word problem that they have a very large number in, but you're still going to write these all in scientific notation. So give it a pause, give it a try, and come on back. Okay, so these would be your solutions. 6 4/10 times 10 to the third. Here's your decimal point. You moved it 1, 2, 3 spaces between the 6 and the 4, and you see it there. 3 spaces is your exponent. This is 5 7/10 times 10 to the 11th. So you move your decimal point 3, 6, 9, 10, 11 times. You stop between the 5 and the 7, making one digit in front of it, and you move 11 spaces. Okay, number 5, you have this very large number, and you moved it. This first group was 3 spaces. There's another 3 spaces, that makes 6. Here's another 3 spaces, that makes 9. And here's 3 more spaces, that makes 12. So here's your 12, number of spaces you moved. You stop between the 9 and the 4, putting one digit out in front of it. You have the 9, decimal point 461, and you don't need any other zeros. Those are not significant digits. Very nice. Okay, here we are. We're going to write a number in standard notation. Sometimes they say standard form. So standard notation and standard form are the same thing. And here we're going to go backwards. We're going to take a number that's in scientific notation and write it in what's called standard notation. So back to the way the numbers always look. So I'm going to write this down a little bit larger so I have some space to work. 3 5/10 times 10 to the 6th. Now I notice that I have a positive exponent. So if I have a positive exponent, this number is not going to get smaller, it's going to get larger. So a positive exponent tells you the number is going to get larger. So here I have my 3 5/10. I'm going to move my decimal point. And I move my decimal point 6 times to the right. So I'm going to move my decimal point 1, 2, 3, 4, 5, 6 times. And I need to fill in all those empty spaces with a 0. So this part is showing my work. This is my work to get the answer. I need to write the answer so it looks normal. So it'll be 3, 5, then 1, 2, 3, 4, 5 zeros. So that would be 3,500,000. And this is the number in standard notation. Okay, so on here it says, explain why the exponent in 3 5/10 times 10 to the 6th is 6, while there are only 5 zeros in 3,500,000. Well, keep in mind that this 6 is not how many zeros, the 6 is how many spaces. So we're going to say the exponent is not how many zeros, it's how many spaces. How many spaces the decimal moves. Don't let them trick you on that one. Okay, so what is the exponent on 10 when you write 5 3/10 in scientific notation? So let's write down 5 3/10. And I'm going to write this in scientific notation. All it is in decimal form right now. Locate your decimal point, and then you only want one digit in front of it. Well, they gave me a number that only had one digit. So actually, I don't move my decimal point at all in this problem. I still have to do times 10 to some power though. So remember, the power represents how many times we move the decimal point. Well, we didn't move the decimal point at all. So that power will be 0 because I never moved the decimal point. So on this one, I'm going to say the exponent is 0. Do not let them trick you. We know this stuff. All right, whose turn? Your turn. Write each number in standard notation. So these 1, 2, 3 problems, they want you to write them in standard notation. So pause and come on back, and we'll take a look together. Okay, so here are my solutions. So here is my decimal point. It sat right here between the 7 and the 0. I have to move it 9 spaces. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 spaces. So that would be the number in standard notation. Notice you don't see the decimal point. It's at the end now, and I don't need to write it down. For problem number 9, here's my decimal point. Move it 5 spaces. So I started here. I went 1, 2, 3, 4, 5 spaces. And the empty spaces here I put in zeros, just like I did on the first problem. So the empty spaces, I get zeros. Okay, in problem number 10, here's where the decimal point is, right beside that 5. So that's where it began. And I have to move 6 spaces. 1, 2, 3, 4, 5, 6. And there's my decimal point. I don't need to write the decimal point down at the very end of a number. So what I did on this problem is any space I had, I filled in a 0. I labeled it grams because we had grams. Word problems, you should label your answers. Okay, very nice, folks.